Can you graph xy equals 1? Stop the video and think for a minute about what this graph might look like. Did you come up with that this is the same thing as y equals 1 over x? And now that's our very favorite rational function graph, and looks just like this. Well, it's not so angular right there. Let's define two vocabulary words: implicit and explicit. Implicit is something that is not directly expressed, and explicit is clearly expressed. This is an example of an implicit function, and here's an example of an explicit function. Let's have a look at these a little more closely. There are two ways to define functions, explicitly and implicitly. An explicit function might be something like y equals 3x plus 4. Y is directly expressed in terms of x, or y's are on one side of the equation and the x's are on the other. Now for an implicit function, an example might be y plus 2xy equals 100. The y's and x's are mixed together on one side, or it could be on both sides. Let's go back and look at x times y equals 1. And we're going to look at this both as an explicit function and an implicit function. An explicit function says that y is expressed directly in terms of x. So here's an example of a function that we can change to an explicit function. If I solve this for y, I get y equals 1 over x. Sometimes it's not possible to do this, but in this case we can, and then we can compare both answers. Now to take the derivative of this, I might want to change this first into x to the negative 1. Now the derivative, it's a power rule, would be equal to negative 1 times x to the negative 2, and I could rewrite that as negative 1 divided by x squared. Nice and easy. To take the derivative of an implicit function, I want to take the derivative of both sides, and I can show that by taking d dx. Remember, that was one symbol for taking the derivative of the left side, and I'm going to take the derivative of the right side. Now the right side is easy. The derivative of 1 is, 0. The derivative of the left side, we have x times y, so you're going to have to remember to use the product rule. So using the product rule, I can let u equal x and v equal y. U prime is just the derivative of x, and that's 1. V prime is the derivative of y. Now again, remember, we really don't know what y is, but anytime we take the derivative of y, we get y prime. Using the rule, I'll get u prime, which is 1, times v, which is y, plus u, which is x, times v prime, which is y prime, and we know that's all equal to 0. Now we want to solve this for y prime, so x y prime is equal to, I can subtract y and move it to the right side. Now solving for y prime, I get negative y divided by x. Now this and this don't exactly look the same, but if you remember what y was, right way back up here, y is equal to 1 over x. If I substitute that in here, I'll get negative 1 over x divided by x, and that's the same thing as negative 1 divided by x squared. Now, yay, we have two answers that are exactly the same. So you can see whether I take the derivative explicitly or implicitly, I do get the same answer. Now I know what you're thinking. Why would I do it this method when explicitly is so much easier? Well, not all functions can be written explicitly. If you can solve a problem explicitly, that would be the first method. But let's look at an example where you can't do that. Let's say we have the cosine of y minus x cubed is equal to 10y squared. This equation would be very difficult to try to solve for y. So here's some guidelines to follow. First, you're going to take the derivative of both sides. The trick is anytime you want to take the derivative of y with respect to x, you're going to have a y prime there. Remember, the chain rule is always very important. And in the end, our goal is to solve for y prime. So let's make sure y prime is just on one side of the equation. So the derivative of cosine is negative sine. Keep what's exactly there the same. And then we need to remember to take the inside, the derivative of the inside, which is y. What's the derivative of y? It's some function. We don't know what it is, let's say, but its derivative is y prime. Minus the derivative of x cubed is 3x squared, and that's equal to the derivative of 10y squared. We could use chain rule, or not chain rule, power rule, and get 20y, reduce that by 1 to y to the 1, but now times the derivative of the inside, which is that y, so we're going to have a y prime there. Now that we've taken the derivative, our goal is to solve it for just y. So let's first move all the y primes to one side. We'll get negative sine of y, y prime, minus 20 y to the 1, so I'm just going to write that as y prime equals, I can move the negative 3x squared to the right side and it'll become just a positive 3x squared. We can factor out a y prime, and that gives us negative sine of y minus 20y, and it's still equal to 3x squared. And our ultimate goal is to solve it for y prime, so if I divide everything by negative sine y minus 20y, that will give us our answer. Notice y prime, or our derivative, right, the answer may have both x's and y's in that answer. Let's look at another example. 2 is y to the 5th plus sine of 2y equals 3x. We're going to start by taking the derivative of both sides, and remembering that every time we take the derivative of y, we need a y prime. Right, so the derivative of y to the 5th is 5y to the 4th times the derivative of the inside, which is y, so that's going to need a y prime. The derivative of sine is cosine of exactly what's there. Now times the derivative of the inside, which is 2y prime, and that's going to be equal to the derivative of 3x is 3. Now again, remember we need to get our y primes on the left side, and yay, they already are. So what we can do is we can factor out the y prime, and we're left with 5y to the 4th plus the cosine of 2y, and I might just add that 2 there in front right here, and that's equal to 3. And our final answer is y prime equals 3 divided by the entire quantity, 5y to the 4th, plus 2 cosine of 2y. Let's look at one more example. Here we have xy minus x minus 3y minus 4 equals 0. Now when we're taking the derivative of xy, remember that's x times y, so we're going to have to use product rule. Here are my u's and my v's on the right side, so we'll get u prime, which is 1, times v, which is y, plus u, which is x, times v prime, which is y prime, right? That's going to be the derivative of the xy, minus x, so the derivative of that is minus 1. The derivative of a negative 3y is minus 3. Don't forget we took the derivative of y, so we need a y prime there. How about the derivative of 4? And that's 0, so I'm not even going to put that down, and that's going to be equal to the derivative of the right side, which is 0. Now I can keep the y primes on the left side and move the y and the minus 1 to the right, so I get xy prime minus 3y prime equals negative y plus 1. If I factor out the y prime and then divide by what's left over, my negative y plus 1 is in the numerator, and in the denominator now is x minus 3. So remember, to take the derivative of an implicit function, you are taking the derivative of both sides. Anytime you take the derivative of y, you're going to tack on a y prime. The chain rule is probably a must in these problems, and our ultimate goal is to solve for y prime, but we will end up with both x's and y's for the most part in our answer.